between curves. These pages here that you have are the same things that you're going to find in your notes and lab assignments, so the first few pages in there. That's why I printed out the first few for you. It includes our lecture notes as well as the first lab assignment. We're going to start off with a little bit of review. Hopefully it's going to feel familiar, and if not, you're going to ask me questions so we can make it feel more familiar. So we're starting with talking about the area between curves. Hopefully, wherever you took Calc 1 before, you learned about the area underneath a curve. So if we have some function here, like the picture that you have on your notes, and you wanted to find this area in here underneath the curve down to the x-axis, how did we find that area?
We take an integral of f of x from a to b.
Integral of f of x from a to b, he says. I like it, he's close. There's one little thing that's missing that really matters.
From left
It's
side.
the other
dx.
formula.
Ah, the dx. There has to be a dx.
Oh,
Especially for those of you who have to go on to Calc 2. It matters because you're going to have multiple variables in here, and you need to know which variables you're integrating with respect to. Everything that you've seen so far, there's only been one variable, and so some of you might have been a little loose with your dx, but it's going to make a difference in what the dx is. Let's tie that into the picture. So I actually have that formula written there on the on the notes up there for you. So let's tie it into the picture. Imagine if I took a small little rectangle somewhere in, oops, that's supposed to be a straight line. Imagine I can draw a straight line, and I took a little skinny little rectangle in here. It doesn't really touch on both sides. So a little skinny rectangle. What's the area of a rectangle? How do I find the area of a rectangle in general? Base times height, length times width, right? Oh. So this distance over here is just some arbitrary x value that I've moved away from the origin, right? Because this is my y-axis and my x-axis. So this distance is some x. We don't know where, I just kind of picked a place to draw it. So how do you find the height right there at this x value? How do I find the height of that rectangle?
X times y.
Say it again?
X times y.
X times y, but so the x is how far this is though, really. It's not the width of the rectangle. So my question is, how tall is this rectangle? What expression could I use for the height of that rectangle? It's a y value. I heard someone say it's a y value. Well, if this is the x value out to say right here, how do I find the y value that goes with that x? I know I'm beating it up, but it's important when we get to what we're doing on Thursday. F of x, I hear you whispering it back there. Y is f of x. So let's say, for example, this happens to be at 4. I would plug 4 into the function to see how tall it is right there. So the height of this rectangle is f of x. That's how tall it is. And then, how wide is this little rectangle, the skinny little red one? We call it a representative slice or a representative rectangle. Anybody know what we use for that? Don't be shy.
x2 minus x1.
I like that. So if I had two different x's right here, if this was an x2 and this was an x1, if he subtracts those, I agree with that. That'd be how wide it is. But let's say those are just ever so close together. I agree x2 minus x1 is the difference. It's a change in x, which we call dx. Change in x, which you could write this way or this way, right? Delta x is an actual change. Dx is an infinitesimally small change in x. You guys have seen this notation before? So this red rectangle right here has a height of f of x and a width of dx. That's how skinny it is, the change in x. So you were totally right, the x2 minus x1, but we're just talking about even smaller. It's going to be what we just call dx, a change in x. A change on the x-axis, some small little change on the x-axis. So the area of just that red rectangle, do you agree is the height times the width? Right, base times height, height times base, whatever. And then this notation, what does this notation mean? Do you guys remember that, what it meant from when you learned it in Calc 1? It's an integral, but what's it tell you you're doing? Anybody remember what it means? The A to B is still good. But what does that integral sign mean? Yes,
Area under the curve.
that's how you find the area of the curve. But is there something else still? Because I only found this rectangle right here, this red one.
Oh,
Ooh, who said that? I heard it. What'd you say?
I said it's the sum of there.
It's the sum of all these expressions. So it's the sum of all these. So this is just the red rectangle. But once I put the integral sign in here, it's the sum of all the rectangles starting at A until I get to B. So imagine if I started over here and had one skinny little rectangle here, that'd be like the first one right here. And I would add that rectangle. And I would add the next one and add the next one and add the next one, starting at A until I got to B. So you need to remember that that integral sign, yes, if I do the area of the curve, you guys are totally right. But it means that you're adding an infinite number of items, and the items are these. I'm adding an infinite number of really skinny little rectangles. You remember the dx was, the width was approaching 0. You had that when you're doing your limit notation. So you learned this before, I just wanted to make sure you understand what it means. I'm really big on you know what it means, because if you know what it means, it's easier to set up the hard ones. If you're guessing and you don't know what it means, then you're not so sure when you're right or you're wrong. So that's how we found the area underneath the curve. Questions on the notation? You saw that before? Okay, so now we're going to move into the area between two curves, maybe similar to the one I have there at the bottom of the page, which looks something like this. I am not an artist, but I'm going to try to recreate it. It's fairly close. So this top one is f of x, and this bottom one is g of x. And I want to find the area, again, starting at A and stopping at B, the area between these curves. So this should be a straight line here. Sorry, I can't draw a straight line. Use your imagination. So starting at A, and I think B is actually before it even intersects, so B is over here somewhere. That match your picture pretty well? Close enough? So I'm trying to find this area in here. Just that part, right? Between this line and that line. So it's obviously different than this. Why? Why is it different?
Because of the second curve.
Yeah, there's a second curve, and that one, what did it have? It went down from the curve and touched the x-axis at y equals 0. This one doesn't do that anymore, so I can't just integrate it. But let's use the same idea. Let's just talk about the area of the small little representative slice. You'll see on the website, they'll ask you to pick the picture that matches the problem, and it'll say, draw the representative rectangle. It'll draw it for you, and you do multiple choice. But in general, we're somewhere in the middle. We just kind of pick somewhere. Oh, I cannot draw today. These are supposed to be straight lines. My pens are slippery. I've been on break. I can't draw straight lines anymore. I cannot draw straight lines. That's a slice. That's horrible, isn't it? Use your imagination. You know that one? The SpongeBob episode, Imagination. Clearly I had kids. Or I watched SpongeBob for fun. I don't know. So area of that rectangle. What's the width of it? The width. Dx again, just like that one, right? That's no different. So the width is dx. What's the height of it?
F of x minus
Beautiful. You guys hear that? Height is f of x minus g of x. It's whatever this y value is minus whatever that y value is. Does that make sense, why we're subtracting those? What about the fact that this one's a negative?
because it's a negative 1.
Yeah, it's okay if it's a negative down there, right? Because imagine, for example, like if this was a 5 and this was a -1, I'm just picking y values, I'm guessing. If those were them, 5 minus -1 would be 6, right? So that would be how tall it is. So it's okay, whether your functions are positive or negative, it's still the top function minus the bottom function. The bigger y value minus the smaller y value. The 5 and 6 I just made up. I'm going to erase them now, so they weren't part of it. Sometimes it helps to put numbers in there to make sense of it. So what's the area of that green rectangle then? How do I write the area of just the green rectangle? Hands? Anybody? Any volunteer? Yes, ma'am?
Area equals integral from a to b, f of x minus g of x dx.
Okay, so we're doing two pieces, because I asked for just the rectangle first, but you're totally right. So this right here, the height times the width, that's the area of just the rectangle, just the one rectangle that I drew. But because we're adding up an infinite number of them, I've already did the whole thing. We put the integral sign here that says, now add all of those, starting at A and stopping at B. This is not much different than what you did in Calc 1. If you want area between curves, you just take the top curve minus the bottom curve and integrate that. Hopefully we all remember how to integrate. So you should have that written down there in the bottom of that front page there, next to that pretty picture. How to find the area between two curves. And here's where it's going to get a little weird, but let me see if there's any questions first before I make it get weird. We'll start doing some concrete examples here in a minute. Okay? If you're not okay, just tell me. I'd rather answer your question now than you turn in your homework and have it be all wrong. That'd be all bad. Okay, so the next picture on page 2 is a little different. Let's try to recreate this one. So now I've got these sideways curves, where this is a curve over here, f of y, and g of y. Ran into it. I've got these two curves, and so no longer is y a function of x, but x is a function of y. And then here's where Math 60 starts making your brain spin a little bit. We're so used to always having y being the function, we're not really used to x being the function. We're going to be doing a lot of functions that go different ways now. So I don't know if you remember the vertical line test to see if something was a function. If I draw a vertical line through here, I'm going to hit it in a couple places. So this is not, y is not a function of x here. But x is some function of y. I like to think of it, if you turn your head sideways. You turn your head sideways and it looks like a function. Look that way. This one passes the horizontal line test now. So you might have functions that you define them in terms of y being your variable instead of x being your variable. But the idea is the same. So if we want the area between these two curves, from some C down here up to some D, guess which way I'm going to draw my rectangles now? Yeah, horizontally. I'm going to draw a little horizontal rectangle. What is the width? The width this way of this horizontal rectangle? I heard somebody say I didn't hear what it was though.
F of y.
F of y, close. I'm just asking for the width though.
D of y?
dy, right, the width, because this, imagine over here, these two little, this little distance right here is how thick it is. So that's a small change in y. We call that dy. Where over here, what do you want? The width here was a small change in x, so we call that width dx, that distance right across there. So this one, because it's a change, I use my fingers actually. I take my fingers and I go, oh look, that's a small change on the y-axis, so that's a dy problem. So there will be some problems that you're setting up with dy's and some that you're setting up with dx's. We agree that one's a dy? Okay, so that's how wide it is. How long is it? Or do you want to call it, if you turn your head sideways, we can still call it the height. How tall is it that way? F of y minus g of y, she says? We agree with that? Did I hear no? I heard some ahas, and I thought I heard a no too. I'm calling it height even though it's sideways. You guys okay with that? It's not really the height unless you turn your head. We call it length, I suppose. And then dy is the width. Did someone say no? I just heard that. Why does the f come before the g? Why isn't it g minus f? I love it. F is larger than g. So remember over here, we took the top one minus the bottom one, because we knew this was the larger y value minus the smaller y value. So now you have to think in terms of x's. Which x is bigger? Further out to the right is bigger. This is the bigger x, this is the smaller x. So you're always going to take the big one minus the small one to get the height. So no matter what they were labeled, instead of top minus bottom, it's going to be right minus left. I'm going to write that on here. Right minus left. Or this one was top minus bottom. Lots of setting up formulas, but no examples yet. You ready to try example 1? You think? Okay. So example 1 says, I'm at the bottom of page 2. Yes? Example 1 says if we want to find the area between two curves, and they give us two curves, how do you suppose we might start? I'll write down those two curves right here. Which red's not erasing. If we want to find the area between this curve and this curve, this is example 1. And all this time setting up these beautiful formulas. What do you think I should do?
Find intersection points.
Yeah, maybe find the intersection points. Maybe even before that, I'm totally with them on that, by the way.
Draw down.
Yeah, maybe try to sketch a graph so you have some idea of what it looks like, so you know it's top, bottom, left, right, whatever. And then I also want to find intersection points because we won't be able to do it without those. I can't stress enough that a lot of the techniques for sketching graphs that you learned maybe in Algebra 2 or Pre-Calc, you want to review those because if you're relying on your calculator every time you have to draw something, it's going to slow you down, and sometimes your calculator isn't completely accurate. And if you have x as a function of y, your calculator can't do it. So I like to at least inspect the kind of graphs I'm looking at. So how about this one? What do we know about that? Y equals x plus 4.
It's a line.
It's a line? What about that line? What can you tell me about it?
It crosses.
Intersect at.
Intercept is at 4,
Slope is
and
1.
the slope is 1. So we could do a rough sketch of that, even if you're an artist like me. So I know the y-intercept is up here at 4. And the slope is 1, which means it's going to have a rise of up 1 over 1. So a rough sketch of it might look something like this. What point is this over here? This one.
-4.
Yeah, -4, 0. Because of the slope, right? So I drew that one, a little rough sketch of it. What is this a graph of? It's a parabola because of the x squared. Now, not everyone can just look at a parabola and graph it. Here, I'll show you my shortcuts. Does it open up or down? Open up or down? How do you
It's
know?
up.
Why? How do you know it's up?
Because x is positive.
Right, because this coefficient is positive, that tells you it opens up. If it had been a negative out front, it would have opened down. So I know it opens up. And what I do is I take that information, and if I can, I find my intercepts. my x-intercepts are really easy to find. So if I want to find the x-intercepts, I set the y equal to 0. Use my fabulous factoring skills. And that tells me that x equals 0 or x equals 2 are my intercepts. Mind you, I still don't know exactly what this graph looks like, but here's what I know. I know it goes through this point and this point, right? 0 and 2. So what else do I know about it? That's the first question I asked. It opens up, right? So if it goes through those 2 points and it opens up, I'm just drawing a rough sketch so I can get this area. It must do something like this. Whoops, I missed. Make that bigger. Something like this. Rough sketch of what, I don't know how low it really goes here. It doesn't really matter because I don't need the exact graph. I'm just trying to draw a rough sketch so I know how to set up the integral. Is okay with how I sketched that pretty quickly? If not, you could have plotted points. You could have used your calculator. I'm old school. I learned calculus without calculators. So what am I looking for in this problem? The area between the two curves. Can you see it? The area between them? What the heck is it? What do I mean, the area between them? I'll take suggestion. You have a suggestion? I see your little brain going.
Negative, where x is equal to -1 to the right from there on.
From
Yeah.
-1 forever?
I guess to where the parabola crosses over the line.
Ah, okay, so I don't know how you got to -1, we'll talk about that in a
Yeah,
second.
whatever
But it
that
looks
is.
like maybe -1 or somewhere, starting here, and then he says until it crosses the line. So it might be that the way you draw your sketch isn't accurate enough to see the enclosed region. So what I'm gonna do is take this parabola and continue drawing it, and I'm gonna take this line and continue drawing it so that they actually enclose an area. So now the enclosed area is this area in here. You might have to extend your graph to actually see that it's just, to the part that's enclosed, you might have to see where they actually cross each other or touch. Be careful, some people will see this down here and think that's enclosed right there. It looks enclosed. Why is it not enclosed right there? Yeah, that axis is not one of my functions. I sometimes will even draw my axes as dashed lines so that I am not tempted to think of them as closing things off. Because your brain sometimes will look at the x-axis or the y-axis and say, hey, that's closing things off. So now we have our picture here. So it looks like roughly -1, maybe -2, because I'm not the best artist. Over here, there's some positive number, I don't know what it is, which goes back to, what's your name again? Chad's suggestion was to find the points of intersection, way back when. I said, yeah, I want to do that, but not yet. If we find out where these intersect, if I know those points right there, then I know where to start and where to stop. So in these pictures, I just gave you, oh, I'm going to start at A and stop at B. But now we need to find out what A and B actually are. So how am I going to do that?
Set the two equations.
Beautiful, set them equal to each other. When will it be true that x plus 4 is equal to x squared minus 2x? Set the equations equal. I want to know, when will this be the same as this? Those are the points of intersection, right? Anyone ever tell you that the hardest part of calculus is the algebra? If they haven't told you yet, you might learn that this semester. There's so much algebra they don't remind you of. So we need to solve this equation. Whenever I have quadratics, I tend to resort to factoring if I can. If I don't, then I'll go into the quadratic formula or something else. But quadratics really have to be set equal to 0 to solve them no matter what. So I'm going to subtract these things to the other side. Subtract x and subtract 4. I'm doing that in my head, so you can follow me on that one. subtracted x, subtracted 4. Both sides. How should I solve that one? Factory is the easiest one. If you're not great at factoring, spend like an hour practicing and your life will get so much better from now on. I have a lot of people say, I don't factor. You want to, it makes life faster. Do it. Factors into x minus 4 and x plus 1. We set each factor equal to 0. We have x equals 4 and x equals negative 1. What are those? Those are our A and our B. Those are the places on the x-axis where these intersect. They start over here at x equals negative 1. Oops, that's a horrible one, negative 1. They start right here at negative 1, and they stop over here, if I can line up, at 4. That tells me that if I actually wanted to know these 2 points, I know what the x is right here. The x is negative 1. I can just plug it in and figure out what the y is. If I wanted to label these, this point right here is negative 1. If I plug it in here, I'll get a 3. That's that point, negative 1, 3. And this point here is 4, 8. Just plug it into the functions to figure out the y values. I don't need the whole point, but I just want to find that's what those are giving us. Those are actual points where they intersect. All of this was really an algebra review to draw the picture. That's what the calculus, or the algebra is the hardest part of calculus. Okay, so now the question I have for you is, do we want to do a top minus bottom, or a right minus left, or could I do either one? I heard a lot of top minus bottoms over here in the side of the room. Can I do right minus left? Sometimes you have options, you know. Who said no? Someone said no. Why no?
Because some right and left is the same curve.
Hmm. I like her words. In some places, the right and the left are the same curve. So if I was to draw a horizontal line, say up here, this function's on the right and that one's on the left. But if I draw it down here, this function's on the right and this function's on the left, and that's the same function. See the problem? So in this case, we can't do a right minus left. There are some that you can do it either way or both ways, and you'll be fine. But it doesn't work for this one because you have to touch different function each time. Now, if I draw vertical lines instead, will I always touch 2 different functions if I draw them vertically?
Yeah.
Yeah, sometimes you might even just want to do that. Here's one here, here's one here. All these vertical lines, they all touch this one on the top and this one on the bottom. See that? So that tells me I want to do it vertically, which means my representative rectangle, I'm just going to put it in the middle here, is going to be vertical. So is this a dx or a dy situation? Dx again, right? That's a small change on the x-axis. So I know that I need dx. I need to take the top function minus the bottom function. The top function is the line, x plus 4, minus the bottom function, which is the parabola. And make sure you put parentheses around that. Right here, parentheses to make sure that you actually subtract the whole function. You guys see that? I see you back there. Lydia, can you see? I see your head going. And what are my bounds here? Negative 1 to 4. Because this says dx, I am taking the x values, negative 1 and 4. If I had been doing a dy problem, I would have used the y values from 3 to 8. So it really depends on the dx or the dy, which is why you want to put that in there. It matters. Questions on how I set that up? Okay. take about 4 minutes and see if you can evaluate that integral. Remember how to do that? Try it. You can pause that if you want to. We're working on that. Start. Let's see if we can work this out and we get the same answer. Let's see if we can get the red pen to erase. It's not erasing.
It's the right concept.
Okay, so we had this integral here that I asked you to evaluate. We had to all dust off our cobwebs in our brains from either break or who never knows how long it's been since you did some integration. The first thing I was recommending that people do is actually distribute the negative sign and combine like terms. You don't have to, but it just cleans things up and gives you less of a mess to do later. So I'm gonna do that first. That becomes x plus 4 minus x squared plus 2x. Plus, right? And I distribute the negative sign. And then from there, I even combine like terms before I do I won't really be using the word antiderivative anymore. I'll just call it, I'm going to integrate or find the integral, which really means the same thing. So I'm going to combine my like terms. I like to put them in decreasing order too, just because it helps me keep track of everything. It doesn't really matter. Negative x squared plus 3x plus 4 dx. If they're not in the same order, you're fine. So now that we've set it up, we know it means find the area under the curve, but this integral sign means find the antiderivative. So it means you have to integrate, which means you take whatever your exponent is, you add 1, divide by that new exponent. Remember all that? That's the part that we weren't all remembering. This is 3x squared over 2. If you had extra terms here, because you didn't combine them, you should still get the same answer. Once I'm done integrating, some of you were asking about the notation, then we write it over here, a straight line saying we still need to evaluate between -1 and 4. When you put this in front, it tells you still need to find the antiderivative. Once you've done that, you put it at the end, which says now we're going to evaluate. And to evaluate, we take the 4, plug it in for all of our x's. So I have -4 cubed over 3 plus 3 times 4 squared over 2 plus 4 times 4. So I plug the 4 into everything. Minus, I now have to plug the -1 into everything. Be careful with your negatives. There's a negative here. And I'm plugging a -1 in for my x. Right? Plus 3 times -1 squared over 2 plus 4 times -1. Still good? Some of you are erasing. It's okay. So this becomes -64 over 3. 4 cubed is 64, I think. Plus 16 times 3. 48 over 2. Well, I can reduce that here in a minute. I'm just kind of doing some simplifying here. Plus 16. Notice I put these parentheses here around this whole expression. If you don't, you're going to lose a sign somewhere and it's going to mess everything up. Make sure you have those. I'm going to leave them here for now while I simplify what's inside there. Is that one going to be positive or negative? Negative? Positive? Ooh, let's take a vote.
No, wait, inside of
The whole thing, this whole expression.
the whole expression is positive.
Positive because
It's gonna be a negative.
the -1 cubed is negative and then there's another negative. Right, so that's 4 negatives. So that's positive 1/3. How about this one? Positive or negative?
Positive.
Positive again, right? Because the -1 squared is positive. So that's 3 over 2. This one's -4. I can do that. Still okay? At this point, we need to distribute this negative sign through here. So I'm going to do that and reduce a few things that I can as I do that. I'll bring it up top here. So I have -64 over 3 that next term will become a 24. This 48 over 2 is now a 24. Plus 16, minus 1/3, minus 3/2, plus 4. Erase this. By the way, for those of you who don't know me, which is most of you, I am human too, and I make mistakes with signs and symbols and whatever, so if I'm ever wrong, just interrupt me and say, Jill, that was supposed to be negative, or it was supposed to be a 7, or whatever. Don't assume that because I know what I'm doing that I'm never wrong. There's a difference. I'm human. I know what I'm doing, but I still make mistakes. Still good here? Now, the only thing I'm gonna do next is combine all the ones that aren't fractions. Actually, I'll put these two together because they're a common denominator. So I have negative 65 over 3. I add all these, 24 plus 16, that's 40 plus 4, 44. Minus 3 over 2. Still with me? We're almost there. What should I do now? Some of you are going to say reach for your calculator, I know. I'm sorry, who said that?
Common denominator.
Common denominator? What's my common denominator? 6. Okay, it's not going to kill us, we can do it. I know we don't like fractions, but doesn't mean we can't do them. So I need this to be a 6, so I'm going to multiply this one by 2 over 2 to get a 6 there. I need this one to be a 6, so I'm going to multiply it by 6 over 6. And I need this one to be a 6, so I'm going to multiply it by 3 over 3. You can handle this. This is negative 130 over 6. Can someone multiply those for me? Can't do that one in my head.
130.
130?
240.
6 times 44.
264.
264? We agree? I heard lots of different numbers. Yeah, I see some nods. 264 over 6. 9 over 6. You good? Did I lose you? Oh, okay, just checking. Saw you looking on here. She's thinking, I could be wrong. Now we're just going to add these all up. That ends up being 134 minus 9. 125? Yeah. Over 6. That's my answer. Doesn't reduce. How many of you got that answer? Oh, about 5, 6, maybe 7 even. Very common, by the way. There's about 400 places to make mistakes there. If I were you, if you didn't get the right answer, I'm not as worried as if you didn't know what to do. Those are two really different things, right? Knowing what to do and making a sign, losing a sign somewhere, or multiplying wrong. Oh, you found a mistake?
No, I was wondering,
Oh.
so for me, I was wondering if it was okay if we did this in our work, if we made the common denominator before we added the ones that are fractions up together.
Oh, you did it way back here?
Yeah.
Yeah, the order that you do it, so he's asking could he get common denominator back here maybe, right? That's
Yes.
fine. You're gonna have to do it eventually, so whatever the order, I just kind of was doing whichever one came to my head. But once you get to here, which order you decide to combine things is totally up to you. I'm not that picky about it. The main thing is I don't want you to go from here to here without me knowing how you got there. Yes.
You want us to be simplified down to one term?
Yes, when you're evaluating an integral, you should just get one answer, so it should be one fraction or one number or whatever. Okay, so let's set up a couple more. We won't have time to work out all the integration part, but let's set up a couple more. We've got somebody from Mesa coming to talk to us a little bit. So I want to look at example 2 on the next page. We're only going to set this one up just because of the interest of time. And this one's one that has x as a function of y, so it's a little bit different. A little bit different than these. So we want the area enclosed by these 4 functions now. 4 functions. Okay, someone don't let me pick the red pen up again. Someone pick up the red one, stop me. It's not erasing. I have x equals y squared. I have y equals x plus 2. y equals -2 and y equals 3. No problem, there's 4 of them now. We want to find the area enclosed by those. I'm going to draw my axes in a different color here, just so they don't get confused. I'm going to draw them faint on purpose. My X and my Y. What is this?
Horizontal parabola.
It's a sideways parabola. We know y equals x squared, right? That's the one that opens this way. So y equals x squared goes up and down. X equals y squared just goes right to left. How do we know if it opens to the right or to the left? Positive, I heard 2 people say because it's positive it opens to the right. So a rough sketch of that one might be this. This is x equals y squared. You just take what you know about parabolas and turn it sideways. When you switch the x's and y's, it kind of turns it sideways. Now, we know how to graph this. Y equals x plus 2. That's just a line, right? So let's just say 2 is right here. It looks something like this. That's a straight line. So there's those 2. What's this? Y equals -2. That's a horizontal line? So -2 is down here roughly? That's a horizontal line right here. That means I need to extend this down and see where it crosses. And y equals +3 is also a horizontal line. Here's 3 right here. Looks like I need to make this one go up a little bit more. This is y equals 3, y equals -2. Can you see the enclosed region? That's the hardest part sometimes, is interpreting your own graph. Where's the region? The enclosed region is here. Oops, I don't want to use buttons. You're too messy. But I'm not touching red either. The enclosed region is in here. Yep. This top minus bottom or right minus left?
Right minus left.
Right minus left for sure, right? Because I can't, if I try to draw a vertical line here, it touches this line and this line over here. But over here it would touch this line and that parabola. And over here it'd be that line. It changes every time, right? Depending on where you draw the verticals. But if I draw them horizontal, I dare you to draw a horizontal one that doesn't always touch this one and this one. Do you agree it always touches those 2, no matter where you draw it? Sometimes it helps to draw a few of them, right? Draw one down here, draw one here, draw one up here. They all touch the same functions on the right and left. So my first question for you, is this a dx or a dy? dy because? Yeah, it's got a small change in the y direction, right? The thickness of these little rectangles, they're all thick, a small change in the y direction. So I know it's a dy. Put your fingers there, like my fingers are on the y-axis here. What do I want to do next? Let's do the bounds next. What goes here and here? -2 to 3, because those are y values, right? Because this says dy, this has to be a y value from here to here. So we're going to start slicing it from here all the way up till there. Instead of left to right, it's bottom to top. So I'm going to start slicing at -2 and keep slicing till I get up to 3. Now there's one little thing we need to do.
Y squared minus
I heard y squared minus.
and then the x plus 2.
Yeah, so I'm going to write that in another color for the minute because it's not quite right. But I like what you're thinking.
We have to change that equation in terms of
Oh,
y.
Right, everything has to be in terms of y. So the reason I wrote it in green is just to make the point. Do you, everyone agree that's going to be the right function minus the left function?
Yeah.
But this is a dy. Which is why, remember I said at the beginning today, I'm like, you better remember to put those on there, it matters. Because this is a dy, everything here has to have a y in it. So this is supposed to be a function of y, and this is supposed to be a function of y. This is x equals y squared. Solve this one for x. This is the function x equals
Y minus
y minus 2. So this is my function of y. So instead of this guy, I can't have him in there because that's a function of x. I'm supposed to have y's. I'm going to rewrite it as from -2 to 3, y squared minus, was it y minus 2? Y minus 2 dy. dy looks like an x, better be careful. I said it. There we go. So this was a perfect example, and that it's not always set up perfectly for you. You might have to do some rearranging so that you can set it up. This was y as a function of x, but we can make it x as a function of y. I'm not going to finish integrating this one just because it takes a little time consuming. Same idea as this guy. I'm more worried about setting them up because that's what's new. You're going to practice on your own. Questions on setting that one up? So put yourself a little note here. Now integrate. I don't have the solutions with me, but I'll figure out what they are. So next time, if you want to know, if you're practicing them for fun, if you want to know if you did it right, I'll tell you what the answers are later. Okay, let's look at example 3. Example 3. Sketch the region, find the area of the region. Okay, great. Just by looking at the equations that they gave you there without sketching them, do you think it's going to be a top, bottom, left, right thing? Can you tell by the way it's given to you? How? Well, you said, who said yes? Is that you?
It's two parabolas.
Yeah, you can see it's two parabolas and it's y equals two parabolas. Like one's y equals, the other one's y equals. They're giving you y as a function of x. You can pretty much see that that's going to be a top minus bottom one. Where this one over here, x was one thing, y was another thing. It wasn't totally obvious here. But because this one has y equals in both cases, it should be pretty easy. So let's get that one started. I'm going to draw the picture a little bit quicker this time, just so we have time to set that last one up. So y equals x squared plus 1. That means it goes through here, got moved up by 1, so there's the first one. Y equals x squared plus 1. It's got moved up by 1. What's the next one look like?
It's about 3, except it goes upside down.
Yeah, it's up 3. 1, 2, 3, but it's upside down. So that's this one. Y equals 3 minus x squared. And then we have these vertical lines of x equals 0 and x equals 2. X equals 0 is right here. I think x equals 0. Where's x equals 2? I didn't label anything here. How do I know where to put it? Is it here? Is it there? Is it over here? See what my problem is? I'm not sure where 2 is. Oh, what should I do? Fix it. I don't know where to put the 2. I'm just trying to figure out where it is on my scale because I draw like a maniac. Yes.
Set these equations equal to each other so that you know where they intersect.
She wants to know what this point is, where they intersect. If we find out where they intersect, then we'll know, like, if this is a 7, then I know where 2 is. It's on the other side. If it's a 1, then 2's on the other side. So we need to know what that point is. Let's find that point of intersection. When is x squared plus 1 equal to 3 minus x squared? That's what we're really wanting to know. That's 2x squared has to equal 2. I move my x squared terms over, my constant terms over. I quite often skip a few algebra steps, do them in my head. If you ever need me to back up, just tell me. x squared has to equal 1. So x equals 1 or negative 1. So that tells me that this right here is negative 1, and this right here is positive 1. So now I know where to draw my x equals 2. X equals 2 is over here. I have to move these over now, they're gonna be in my way. Move them up and down. So if that's 1, 2's over here somewhere. There's my vertical line at 2. Where's the region enclosed by this?
You're just gonna almost more.
I couldn't hear you.
So when that just neglected and we from -1 to 1.
Well, here's the problem. They want enclosed by all 3 of them, or excuse me, all 4 of them. And,
Oh, we're
Zero.
doing selected to x.
yeah, so between 0 and 2 pretty much keeps me between these 2 lines. Remember, x equals 0 is this one, and x equals 2 is that one. So I have to stay between those 2. But then I also have to stay between the parabolas. I'm actually going to extend these out and make them touch just so, because I can't reach it higher. Wherever this reaches here, and this might reach somewhere over here, I don't really know where. This, I have the red one in my hand because I almost used it. Almost used it. This part right here is in between the 0 and 2 and in between the parabolas. And this part over here, I like the picture, I think it looks like a fish. See the fish? That part over there is also between those parabolas and between 0 and 2. What's the problem?
It's both.
What'd you say?
Is it both?
It's both, so how am I gonna find the area of both? Ah, 2 separate integrals, right? Let's figure out the integral. Why do I need 2 separate ones? I agree I need 2 separate ones, but why?
Because
Go ahead. Because?
like the 2 parabolas, they intersect at x equals 1 right there. So
Is it because?
I don't know how to explain it. So.
That's okay, I like your thinking, it makes me happy. What'd you say?
Oh, is it because the top and the bottom changed?
Aha, the top and the bottom change. So when I draw a little rectangle here, it touches the upside down parabola and then the other one. But when I draw a rectangle over here, now the upside down one's on the bottom and the other one's on the top. See how they flip which one's the top minus the bottom? So if ever your functions change, you just have to break it up into 2 or more integrals. So I'm going to integrate from here to here, and then from there to there. So the first one goes from 0 to 1 for my x's. Which one's on the top? Which one is that? It's 3 minus x squared. I heard someone say. That's 3 minus x squared minus x squared plus 1. It's a b. It's a really sloppy b. Right? This one minus that one from 0 to 1. Plus, from 1 to 2, the other way around, right? X squared plus 1 is now on top. And 3 minus x squared is on the bottom. And there are times when you might have to break it up into 3 different integrals or something. It all depends on what happens on which one's on the top and the bottom and so forth. And then, of course, there's a lot of integration and evaluating there. Questions? Anything great about to explain? Not yet? If you walked out right now and had to do a bunch of these, how confident are we could do it? Got a couple thumbs up, a couple nods. Other of you not giving me anything, I don't know what that means. No questions? Okay, so that last one there where it says practice wants you to do it both ways. find it with respect to x and with respect to y, meaning do it one way with a dx and then do the same problem again with a dy. Guess what the answers should be? The same. Now, they might look different, but they will be the same answers. Let's see if we can get this one going. What is that first one equation of? Y equals the square root of x minus 1. Half a parabola. When you have those square roots like that, it's usually half a parabola. Not always. So this was the one we said was half a parabola. If you don't recognize it as half a parabola, you could square both sides and you'd see a little bit better. You'd have y squared and then x minus 1, so it looks more like a parabola then. So that's half a parabola. Okay, what's the other one? Write it down, let's write it down. X minus y equals 1. There we go. Half a parabola,
First quadrant.
first quadrant, it actually starts over here at 1, and it looks something like this. If you want to square both sides, you'd end up with x equals y squared plus 1, it would make more sense. So there's that graph. And x minus y equals 1 is an equation of a line. Sometimes it helps to solve for y so you can recognize it. Y equals x minus 1, if you want to rearrange it. Right, move the y over, move the 1 over. That's just the equation of a line. Looks something like, it goes through 1, 0, looks something like this. That's the right graph. So here's x minus y equals 1, and this one was y equals the square root of x minus 1. So I have this little region here, this little half a parabola, and that little straight line. Do I have everything I need to start setting up integrals? Top, bottom, left, right, endpoints? Yeah? No? Although we're controversy. Yeah, I know this is a 1 right here. What point is this right here, if I have to label this point? 0, 1? 1, 0. Be careful, it's 1, 0. That's 1, 0. It matters which is x and which is y. What point is this? Right here. Some of you already figured it out, but I can't tell by looking at it, especially if you draw like I do. So how am I going to find it?
Set the two equations.
Set them equal to each other? Hey, Nicole, come on in. Give me 2 more minutes. So I'm going to set these equations equal to each other. Which ones? I got a couple of different equations going on here. Which ones am I setting equal?
X minus 1 equals x minus 1.
Yeah, this is y equals and this is y equals, so we set the 2 y values equal. So I'm going to go ahead and take this y value equal to this y value. That's ugly. How do I solve that? Square both sides. Right, square both sides. X minus 1 equals, make sure you multiply that out. It is not x squared minus 1. X minus 1 times x minus 1 will give you this. If you don't know where that came from, make yourself a little note to do FOIL later. That's where that came from. And then I'm going to put everything on one side. So that's x squared minus 3x plus 2. And then, factor, someone just said it, factor. X minus 1, x minus 2. Lots and lots of algebra today. Day 1. 1 and 2. We already knew the 1. So now I know that this one is x equals 2. What's the y value? Yeah, just plug it in, either here or here. So it's 2, 1. Okay, I have everything I need. I should be able to set them up now, no problem. So the problem, which one came first, dx or dy? I don't have my notes in front of me. Which one did it ask for first?
Respect to X.
X first? Okay. So the first one we want is the dx problem. For a dx, let's do the bounds first. Where is x starting and where is x stopping? The first x and the second x, from 1 to 2? And we're going to take top minus bottom or right minus left? It's top minus bottom we're doing x's, right? The top function minus the bottom function. And they have to all be in terms of x. Lucky for us, they are. This is my top function. And this is my bottom function. Top function and bottom function. There's half of it. So there it is with respect to x. And now I want to do the same problem with respect to y. What are the bounds for the y's? 0 to 1?
Yep.
Right, the y values go from 0 up to 1. And I have a little bit of a problem. What's the problem? I need my equations in terms of y's here to put these in here. I can't put the x's in here. They have to be in terms of y. So I have to solve each of these for x. Solve for x. This one's a little bit quicker. These are all equivalent here. So if I just add 1 to the other side, excuse me, add y to the other side, this is that one. X equals 1 plus y. How do I solve this for x? Square both sides. Y squared equals x minus 1. Add 1 to both sides. Okay. Why did I do that?
They wanted it in terms of what?
I need everything in terms of y. So now which function comes first? The line or the parabola? The line, why? That's on the right minus the left. So the line is on the right, so the line is 1 plus y, minus the function on the left, which was the parabola, y squared plus 1. Look at these two very different integrals. If you evaluated both of them, you'd get exactly the same answer. Questions? Okay, so Nicole is here, and she wants to chat with you guys. Nicole's from the Mesa Center. Some of you may know about the Mesa Center, but if not, she's going to tell you all kinds of cool things about it.